Number 10 is an interesting question. It deals with two velocities. I have this rock on top of a huge cliff, 43 meters, so quite scary if you were to fall off of there. And the person can kick really quickly, 19 meters per second. And they kick that perfectly horizontally here. So the first question is, how long does it take for the stone to fall to the water? So here I want to know the time that it takes to go all the way down and splash into the water. And it's kind of neat. You can actually calculate height if you can time how long something falls as well, which we're not doing here, but just kind of as a side note. So here I am going to minimize this and then set it up here. So once again, I have my vertical info. Okay. Vertical info meaning stuff just dealing with up and down. So here I know my acceleration due to gravity is 9.81 meters per second squared. My initial velocity, if it's just sitting there, it's 19 meters per second horizontally, but vertically it's actually 0. My final velocity, I don't know, and I actually don't need that right now. And my time I'm looking for, and my distance I know to be 43 meters. So again, looking at your kinematic equations, I want one that involves distance, initial velocity and acceleration, and time. So that one is my change in distance is my initial velocity times my time plus half of acceleration due to gravity times time squared. My initial velocity is 0, so I can cross that out. And I'm left with my change in distance is 1/2 times gravity times delta t squared. Now, in physics, algebra is very important. And here I'm going to kind of do a shortcut because I kind of did this one in the last video. If I multiply both sides by 2, I'll do that in pink here. Multiply both sides by 2. Divide both sides by g. And then take the square root of them to figure out what my t is there. I can kind of do this in one step. So here I times both sides by 2, so I get 2 times delta d. Divided both sides by g, and then t squared would equal this, but delta t would just be that all square rooted. So if I stick my info in here, 2 times 43 all over 9.8, my time until it hits the water is going to be 0.936 seconds. 0.936 seconds. So let's try that one out. Let's see, this was number 10. 0.936 and submit. And just wait while it's thinking there. Oops. Okay, well, let's assume it's correct, as my program here is taking a little while, so I'm going to minimize out of that, and I'm going to go on to the next part. Okay, so the next part here, I'll kind of draw a line. It's asking me the final velocity. So if I draw this kind of quickly, I have this, it's going to fall down, and its velocity at the end here is going to be at an angle, and that will be my velocity going down and my velocity going to the side added up. So my velocity in the x direction, because there's no acceleration in that direction, it's going to be the same as it was before, which is 19 meters per second. Now I want to figure out my velocity in the y, because there's a negative acceleration there, so I'm going to figure out what this is. Now, I know acceleration is equal to v2 minus v1 all over change in time. And I know my initial velocity is 0, so I can get rid of that. So acceleration will be my final velocity divided by my time. And if I multiply both sides by time here, whoops, I shouldn't have crossed that out. Delta t. My final velocity in the y direction is going to be acceleration times time. So if I work that out, I get 9.8 meters per second squared times 0.936 seconds. And one of those seconds will cancel with one down there, and I'll be left with meters per second. So my final velocity in the y is going to be 9.185 meters per second. And that is going down. So I know my velocity going down, I know my velocity here, and that would be going to the right. And now I need to figure out what my resultant velocity is going to be. So I'm going to do that in this little space remaining here. So pretty much my total velocity, I'm using Pythagorean's theorem here, is going to be my y velocity plus my x velocity. So this would be a squared plus b squared equals c squared. So here's a and b squared, here's my c squared. But rather than having squared there, I'll square root that right away. So my total is going to be the square root of 9.185 squared plus 19 squared. And just because I'm running out of room here, when I work that out, I should get 21.1 meters per second. Right there. Yeah, my program is not working, so I can't put that in, but that is how you would solve questions like this.